Hello, my name is Deja Crossman, and today I'll be presenting on collaborative strategies in higher education. My focus will be on how collaboration can strengthen science instruction, particularly through curriculum revision. I'll begin by showing how biotechnology can be integrated into secondary science programs, and then I'll transition into strategies for enhancing online learning experiences. Both parts highlight the importance of teamwork, communication, and shared expertise in achieving better outcomes for students. I chose biotechnology as the focus area because it is one of the fastest growing fields in science. It has direct applications in healthcare, genetics, agriculture, and environmental science. By embedding biotechnology into secondary science programs, we give students exposure to real world techniques such as DNA analysis or microbiology experiments that prepare them for future careers. Beyond technical skills, biotechnology also raises important ethical questions like genetic modification or bioethics that help students develop critical thinking and decision making skills. This makes it a powerful area for curriculum innovation. To ensure this curriculum revision is successful, I propose forming an advisory committee. The committee's purpose is to guide the revision process, making sure the program remains academically rigorous while also reflecting industry needs. This group will serve as a bridge between the classroom and the professional world, ensuring that what we teach is not only scientifically accurate, but also relevant to the skills students need in college and the workforce. Our committee will include four key stakeholders. First, a biotech industry professional who can provide insight into current workforce demands and emerging technologies. Second, a university science faculty member who uses our curriculum, aligns it with higher education expectations, and prepares students for advanced study. Third, a peer high school science teacher who brings practical classroom experience and can help adapt content for different learning levels. And finally, a student or alumni representative who offers a learner's perspective and helps us identify gaps between what is taught and what is actually useful. Together, these voices can create a well-rounded advisory team. Keep communication effective, we'll use structured feedback loops. This means holding monthly virtual meetings with clear agendas so discussions stay focused and productive. We'll also use a shared digital workspace where members can upload resources, comment on drafts, and track progress in real time. Finally, we'll distribute anonymous surveys to capture honest input, especially from students or alumni who may feel hesitant to speak up in meetings. These feedback loops ensure that all voices are heard consistently throughout the process. Another strategy is co-designing workshops. These will be held each semester and will bring together committee members to collaboratively design lab modules, lab lesson plans, and assessments. By using design thinking, we can brainstorm, prototype, and test ideas in a structured way. For example, we may co-create a lab activity on genetic engineering. We can test it in a classroom and then redefine it based on student feedback. This hands-on interactive process ensures that the curriculum is both innovative and practical. Through this collaboration, we expect several outcomes. First, an updated curriculum that includes biotechnology lab modules, giving students real-world skills. Second, the integration of industry certifications, such as lab safety or data analysis tools, which make students more competitive for internships and jobs. And third, improve student engagement and readiness for post-secondary opportunities, whether that's college, technical training, or direct entry into the workforce. Ultimately, this process strengthens both the program and the students it serves. Okay, so now that we've explored how collaboration can improve curriculum design, let's shift to another important challenge, which is enhancing online science learning experiences. This especially is relevant in today, as more students are engaged with digital platforms and need meaningful interactive learning opportunities. I selected scenario 3, which involves an online science course that has received negative feedback. Students reported feeling disengaged and struggled to follow the material, which has led to dissatisfaction and low performance. This is a common challenge faced in online education, where the lack of face-to-face interaction can have students to feel isolated. Addressing this issue requires collaboration between faculty, instructional designers, and students themselves. The main needs are to improve the clarity and structure of the course and to increase student engagement. Right now, the course may be too text-heavy or lack interactive elements. Our goals are to redesign the course so it is more accessible, to promote active learning through multimedia and collaboration, and to foster a stronger sense of community in the virtual classroom. In other words, we want students to feel connected, supported, and motivated to succeed. To address this, 3 stakeholders will be involved. The lead science faculty, who oversees the content and ensures scientific accuracy. The instructional designer, who specializes in creating engaging online learning environments and can integrate multimedia tools. And finally, a student representative, who provides feedback on usability and engagement, ensuring that the redesign truly meets learners' needs. Together, these stakeholders balance academic rigor, technological design, and student experience. We'll use a combination of communication tools to support collaboration. Microsoft Teams will allow for real-time meetings and breakout discussions. Surveys will help us to gather ongoing feedback from students about what's working and what is not. And interactive tools like Padlet or Jamboard will encourage peer-to-peer collaboration, brainstorming, and sharing of ideas. These tools are not only to support the redesign process, but also to model the kind of interactive learning we want to see in the course itself. During the redesigning phase, we'll hold weekly meetings to keep momentum and address issues quickly. Once the course is launched, we'll shift to bi-weekly student feedback sessions to monitor how learners are responding. In addition, we'll hold monthly progress reviews with all stakeholders to evaluate outcomes and make adjustments. A shared dashboard will be used to track progress, ensuring transparency and accountability throughout the process. By implementing this plan, we anticipate several positive results. Students will feel more engaged and satisfied with their online learning experience. Completion rates will improve as students find the course more accessible and motivating. And the redesigning course will align more closely with in-person learning outcomes, ensuring consistency across different formats. Ultimately, this collaboration process strengthens both teaching and learning. As we conclude, I want to highlight 3 key takeaways from this presentation. First, collaboration, curriculum revision. By working together, faculty, industry professionals, students, and peers, we ensure that science education remains relevant, rigorous, and aligned with the skills students need in the future. Collaboration is not just a process, it's the foundation for building programs that truly prepare learners for real world challenges. Second, the enhancement of online science learning. Strategic use of digital platforms allow us to make science education more accessible, interactive, and engaging. When we integrate tools like video conferencing, collaborative whiteboards, and feedback surveys, we create online environments that mirror the energy and connection in person classrooms. This is especially important for keeping students motivated and supported in virtual spaces. Finally, preparing students for the future.